Hi guys, so today we're going to be looking at 4.6, the fundamental theorems of algebra. So, the fundamental theorem of algebra states that for the theorem, if f of x is a polynomial of a degree of n, where n is greater than 0, then the equations of f of x equaling to 0 has at least one solution in the set of complex numbers. And also another description is that if the polynomial of the degree n, where n is greater than 0, then the equation of the f of x equaling 0 has exactly n solutions provided. So what that means is that based off of the degree of the polynomial, for example, if I were to look at this polynomial right here, we see that the degree here is 1. That means the number of solutions will also be 1 as well. So based off of the degree that's given, we can determine how many solutions there will be to the polynomial equation. So over here, we have the degree of 2. That means that we'll receive 2 solutions, which is shown here. We got 2 solutions provided from either factoring or solving for x. Over here, we have the degree of 3, which means that we're going to have 3 solutions. As we can see here, we get 2. We also get negative 1 plus I times square root of 3. And we also get here negative 1 minus I times square root of 3. So shows 3 solutions. Last one, again, the degree is power of 3. And so we received 3 solutions. So that kind of helps us get a general understanding of how many solutions we should receive whenever we're factoring out these polynomial functions. So, for example, if we're asked to find all the zeros of the polynomial function x to the power 5 plus x to the power 3 minus 2x squared minus 12x minus 8, first thing that I want to do is use the synthetic division to identify what my first factor could be. And if you can recall from last video, I'm going to be using the P over Q format. And when I'm using the P over Q format, the constant 8 will go on top, and our leading coefficient, which is going to be imaginary 1, is going to be on the bottom. And I need to identify all the factors for both 8 and 1. For 8, if I'm looking for all the factors of 8, I know that we have 1 times 8. We also have 2 times 4, and I believe that's it. And for 1, we just have 1 times 1, which makes it easy. So on the top, I have possibilities of being positive or negative 1. There's also positive or negative 2, positive or negative 4, and positive or negative 8. On the bottom, the only one that's possible as a factor would be just 1. So it's kind of nice because we just know that the last one is going to be just all 1s on the bottom. 1, 1, 1, and 1. And so if I were to simplify these fractions, I just get plus or minus 1, 2, 4, and 8. And those are the possible factors of the synthetic or the polynomial function. So let's create the synthetic division. Right here, I have my synthetic divisor. And I need to write down the first terms. If we have here x to the power 5 plus 3, x to the power 5 plus x to the power 3 minus 2x squared minus 12x minus 8. Just a reminder, whenever you're dealing with synthetic division, you have to have the powers in descending order. So right here, we're missing the x to the power 4. So I need to write down the x to the power 5 plus 0 x to the power 4 plus x to the power 3 minus 2x squared minus 12x minus 8. And so my leading coefficients are 1, 0, 1, negative 2, negative 12, and negative 8. So right here, that's what I'll write. We have 1, 0, 1, negative 2, negative 12, and negative 8. Cool. Just make this a little bit bigger. And then on the side, I'll try out x equaling to 1 first. So I'll use positive 1, see if that works out. Drop down my 1, and then this becomes 1, 1, 1, 2, 2, 0, 0, negative 12, and this just becomes negative 12. So this one definitely doesn't work since we get negative 20 as our answer. Let's try out negative 1 and see if that works. So I'll copy this, paste this to the right over here, and I'm gonna see if instead of using positive 1, I will use instead negative 1. So all of these are gone, disappear. I'm trying out negative 1 instead. Drop down the 1. I get here negative 1, negative 1, 1, 2, negative 2, negative 4, 4, negative 8, and this becomes positive 8. So definitely negative 1 is a factor of the polynomial. So I know for sure x plus 1 works, and my leftover here is x to the power 4 minus x to the power 3 plus 2x squared minus 4x minus 8. And it seems like I can still factor this out using the synthetic division. So that's what I'll do. So again, over here, I'll try out using the synthetic division. And it seems like we're still using the same exact numbers as over here in the P and Q because we still have the 8 over the 1. So I'll still use and try out negative 1 and see if that works. We have here 1, negative 1, 2, negative 4, and negative 8 based off of the coefficients provided over here. Negative 1 and 2, negative 4, and negative 8. So again, dropping down the 1, I get negative 1. This becomes negative 2, 2, 4. Negative 4 gives me negative 8. 8 gives me 0. So again, this works out. It's a factor. So I'm going to take my expression from over here because again, I already took out the x plus 1 factor. So I need to drop that down over here. And I have my new factor from the negative 1. So I have another x plus 1. And again, my leftovers are going to be on the side. So we get x to the power of 3 minus 2x squared plus 4x minus 8. And that would be it. And so that would be my new factor. And from here, I could still factor out my x to the power 3 minus 2x squared plus 4x minus 8. I can use the grouping method. That would be easier. I can take out from here an x squared from both of these two. And I could take out a 4 from both of these two. When I do that, I get x squared. This becomes x minus 2. And this would be 4x minus 2. So my new factor would be x squared plus 4 times x minus 2. And so in total, if I drop down these two factors that I received already, I would get here x plus 1 times x plus 1 times x to the power 2 plus 4 times x minus 2. Cool. Last thing to do is just find out all my zeros. And so I could just separate them into each different equations. So x plus 1 equals to 0, x plus 1 again equals to 0, x squared plus 4 equals to 0, and x minus 2 equaling to 0. Solve it. Minus 1 on both sides. I get here, hold on, sorry. I get here x equaling to negative 1. This one, again, subtracting 1 on both sides. I am left with x equaling to negative 1 again. Over here, if I subtract 4 to both sides, then I'm left with x squared equaling to negative 4. And then I could square root the x squared. And I could square root the negative 4. Oops, why is it doing that? Okay, that's fine. And then from here, I get x equaling to 2i, since, again, there's a negative inside the square root. Last one. Oh, and then also, not just 2i, has to be positive or negative 2i, since we are square rooting. So plus or minus 2i. Last one, gonna add 2 to both sides. When I add 2 to both sides, I'm left with x equaling to 2. And so in the end, we're supposed to get 5 solutions, since our degree of the polynomial is 5. And we do receive 5 solutions. The 5 solutions that we received are negative 1, positive 2i, negative 2i, and positive 2. 1, 2, 3, 4, 5 solutions. Done. So that would be my final answer. Okay, let's try out the next one, which is the theorem of complex conjugates theorem. If a polynomial function with real coefficients and a plus bi is an imaginary 0, then a minus bi is also a 0 of the function. So, for example, we're asked to write a polynomial function, and we're given the zeros 2 and 3i. If I were to write down these factors, not only would I have here x, oops, sorry, I'm gonna use brackets. Not only would I have x minus the 3 plus I, but I would also need the factor where x is subtracting 3 minus I as well, based off of the complex conjugates theorem. And again, don't forget the other one. The other 0 was 2, so my other factor was x minus 2. Once I do that, I can start rearranging the parentheses to make it easier for me to multiply. So I'll rearrange it where x is subtracting with 3 and put the parenthesis there instead. And x minus 3 again, minus I, and leave the brackets on the other side. Drop down the x minus 2 as well. And from here, again, we can use the a squared minus b squared method, where a minus b is multiplying with a plus b, because we can consider this to be our a value, and this I would be considered my b value. So again, over here, if this was considered my a value, they would be subtracting with the b value. So from here, I can get x minus 3 squared minus I squared. And then, again, x minus 2 is just being dropped down. From here, I just have to solve for all of them. So x minus 3 squared gives me x to the power of 2 minus 6x plus 9. And then I squared, that just equals to being negative 1. And all of this is being dropped down. Last thing to do, combine 9 minus negative 1, which is 10. and then drop down everything else. And the last thing to do is just multiply x minus 2 times x squared minus 6x plus 10, which would give me x times x squared first, and that equals to x to the power of 3. Then x times negative 6 gives me negative 6x to the power of 2. And we also have here x times 10, which is just equal to positive 10x. On the other side, 2 times x squared equals to negative 2x squared. We also have here negative 2 times negative 6x, which equals to positive 12x. And the last one is negative 2 times 10. And that equals to negative 20. Okay. Last thing to do, combine just the like terms. Like terms are, well, x to the power 3 is on its own, doesn't have a like term, so I'll just bring that to the bottom. Negative 6x squared can combine with the negative 2x squared, which gives me negative 8x squared. And then I can also combine the 10x with the 12x. That equals to 22x. And the last one here is the 20, or the negative 20, which can just be dropped down since there's no like terms. And so that would be my final answer in the end. Okay, so hopefully this helped. Good luck.